All right, everybody. Welcome back to the stream. And so if you looked at the intro card and you were wondering, oh, what's going on? Am I in the wrong week? You are not in the wrong week. I just forgot to update the intro card. I'm very sorry about that. So yeah, stuff happens. Life is complicated at times, right? So I've tried something new. So you might see, this little area here. And if things work out all right, we should be able to see the chat there. So why don't you just say hello, and then we can see if stuff pops up there. So I heard my own chime, so that seems to be working. Let's see if I can see you folks as well. So please give it a try. Say hello, say where you're dialing in from, and what's your choice of beverage. All right, so we see folks coming in. So let me quickly rearrange my screen a little bit, because I think that way it's going to be easier. All right, so we've got Lars, we've got Clemens. Let's see who else will be joining. And I think I'm going to move this over here, and then I'll just make this larger like this. Let's see how that works. All right, cool. Awesome. So this seems to be working. Oh, and by the way, so if you notice a lag between you typing or you sending a message and then it appearing on screen, that is the lag that I also experience, because I'm streaming this in 4K, and that means that things are a little bit slower. There is about half a minute of lag. I've considered doing this at a lower resolution, but I thought it would be better to have higher resolution so it's easier to see what's going on screen. But I'm happy to hear your opinion. So if you think, yeah, we can do this at a lower resolution to get lower latency as well, let me know. And then we can try this out the next time. Okay, so what we are going to do today is we're going to continue working on the Firestore implementation. And last time we worked on adding stuff to Firestore and setting up a live listener. And this time around, we're going to finish the implementation. And there are a couple of things that also were missing. So, and Clemens actually had a couple of questions, and I thought it would be good to take a look at them. So let's do that. All right, so let's move that a little bit out of the way so we can focus on what's important. And also let me hide the bookmark bar. So there were a couple of things. So first of all, Clemens pointed out that the way that I implemented toggle read and toggle flag are dangerous, and I agree. So let's look at the implementation really quick to see what Clemens meant here. So if we look at what's going on here, we have our in-memory artifact store, and in this in-memory artifact store we have those methods here, the toggle read and the toggle flagged methods. And what's happening here is we take this artifact and then we change this one value here, and we then update the entire artifact. So if we go in here, you can see that we're looking for the artifact, and then we just replace it. And that seems like a pretty innocent operation, But we might run into a situation where somebody else, some part of the application modifies a different field of the artifact, and when we do it this way, we will just override it. In the current state of the application, I think the chances of this happening are pretty slim because there is not really a lot of things going on at the same time, but we might end up in a situation where this is actually a problem. So how can we fix it? Well, you might remember last time when I was implementing this, the GitHub Copilot actually suggested using the same way to find the artifact when doing the toggle read. So instead of doing what we do now, let's do it the way that it suggested. And okay, let me do it this way actually. Okay, so we'll just copy this and then bring it down here. And then instead of doing artifacts index equals artifact, we will do this dot is red dot toggle. So this should be better, right? And then just going to do the same down here. But now instead of using the is red, we will use the is flagged, and that should be fine. All right, so let's run this and see if it still works. Let's see, where is our similar? Oh, it's still compiling. Okay. All right. So build succeeded. And let me grab the simulator and put it here. So there we go. Okay, all right, so the application is starting up. And any minute now, we should see the UI. Come on. All right, so here we go. Okay, so let's try this out. So if we pull this to the right, okay, so this is not working. Okay. All right, what's with that? So it's not working. Okay, so why is that? Oh, it's probably not readable, is it? So let's put a breakpoint here and then just try again. Oh, what's that? Are we not calling this? Oh, I know, because we're already connected to the Firestore thing. Oh, well, all right. So let's just quickly dial this back. So we are in the artifact list screen, I think. And then, yes, here we go. Okay, so, and instead of fetching it from the environment, we'll just quickly use the state store here. Let's see. Okay, so compiling, build succeeded. Here is the application, and then, okay, so at least we're hitting the breakpoint. Okay, so this seems to be working. What about this? Yeah, this works. Okay, so and I think this is a safer implementation now. We should not immediately run into any issues. So thanks for bringing this up. And with that, let me go back here to go back to our Firestore implementation. And then let's look at the other question that Clemens had. So when adding a document, we currently don't keep track of the returned document reference. That's true. Wouldn't it make sense to keep that reference to have one less round trip when performing changes on the document? Also, do you know if it's possible to get the document ID into a field of the object when we are deserializing? Yes, so that is a very good question, and it is something that we didn't do last time around. And let me actually go into the documentation and show you how this is done. So let me grab the documentation window, or let's go into the console first. Okay, so here we are. Okay, so let's go to the Firebase documentation, firebase.com, build Firestore, and we're looking for the part, the part of the documentation where it talks about mapping documents. So, and I think that was under solutions last time we had a look. Or maybe not. Was it here? Structured data, add data. Sometimes it's easier to just search. Yeah, I meant Codable. There we go. Map Cloud Firestore data with Swift Codable. All right, so this is how you should not do it. So we first talk about the old way of mapping data, where you have your dictionary and then map everything manually. And last time I told you that doing this is, a lot of work. It's cumbersome and error prone. And this is why we support Codable. So a little bit further down here, you see this very simple book struct, which has just a couple of fields here. And you will notice this add document ID. And add document ID is a property wrapper that enables us to map the document ID into a field on a struct. And that is what we want to do. So again, looking at the data in our Firestore instance, we have all those documents that are in the artifacts collection here. So we have a document here, a document here, and a document here. And on the right-hand side, we see all the attributes of the documents. And here is the document ID. So that is what we want to map into our struct. Okay, so let's get back into Xcode. And let me make a little bit more space. And then we will go into the artifact. And so here we mark it up as Codable. And now I'm going to first import Firebase Firestore. And then we're going to mark this up as add document ID. Oops. Okay. Public. Okay. So that was the first step. And we can see if this works by running the application, and then in our listener here, we can set a breakpoint and see, have a look at the data that we get. So let's run the application real quick. Okay, so here is the breakpoint. Here is our document, and then let's see let's do a step and another one. Okay, so maybe what we'll need to do is let's do it like this. Okay, so I need an intermediate variable so to make it easier to inspect it. Okay, so let's step over, and now here we have our document, and here we have our document ID. So let me zoom this in. So it starts with 0VWQ, and let's take a quick look at our instance here. And here we go. Here is our document that we're currently mapping, and you can see that we're mapping this onto the ID field. Okay, and so on and so forth for all of the other documents. Awesome. Okay, so by doing that, we get access to the document ID, and that's actually really important for some of the operations that we want to do later, because when we want to update a document, we need the reference to the document path. So really good question there, and I'm happy that we are now in a much better place. Let me also, I think there was another part to the question. Let me go back. I need to find my window. Here we go. Yeah, I think that was the main question there. Okay, so, and then I think there was another question around around receiving all those updates in the snapshot listener, right? So let's take a look at that again, and maybe what we can do is we can firstly, let me remove that. So I want to log whenever the snapshot listener receives a snapshot. So we are here, and then what we can do is, let's see if we can, perfect. So unterminated string. Okay, so I want to log out the number of documents that we receive. So this should be it. So let's run the application, and then we should see that it says, well, you know, you got 6 documents or something like that. Okay, received snapshot with 9 documents. And that is the number of documents that we have in our query here. So now the question is, do we get all those documents every single time that we get an update? And we can quickly check this by making a change here. So let me just change this value here. Hello. Update. Okay, so the update fired. And you can see that the snapshot listener says, well, I received 9 documents. So it seems like we receive all those 9 documents over and over and over again. And that might seem like it's wasteful, because you might worry that we are transferring all of those documents over the wire over and over again. And you know, for 9 documents, that might not be an issue, but if you have hundreds or maybe thousands of documents, it might be. So what can we do to find this out? And I've added a little statement here. We can turn on logging. So let's turn on Firestore logging and see what's really happening when behind the scenes. So we should see a lot more output now. Yeah, so let's see. Let's do this again. I'm not sure if this actually fired. Okay. I was kind of hoping that we would see the gRPC messages. Okay, so let me quickly double check something. So first of all, let's try and make an update. So okay, so this is not giving us more updates. Let's double check this is actually running. Okay, we hit the breakpoint. Okay, all right, so time to look into my reference and see what I did. Okay, so I wonder if I need to set a different launch argument. You know what? When in doubt, search the documentation. Okay, so how to set log level for Firestore. Okay, so this is for the web, Android, Swift. Well, this is what you need to do. Okay, Java, Swift. Interesting. Okay, and I also remember that it did work the last time I tried it. Oh, there we go. Oh, look at that. I was just too impatient. Okay, so here are all the log message we get from Firestore. So, and you can see a lot of stuff going on here. It says something like committing transactions, and LevelDB is the database that we use to cache all the data. So let's take a look at what is going on here. So here we have the watch stream, and you can see that it is watching this path in the database, and it says I'm watching this collection here, and you can also see the sorting order, and here is the resume token so that it can resume the connection, and here you can see that it's expecting 9 documents. Okay. So now that we have this stream, let's try making an update. So I'm going to move this to the right. Let's make sure that we can see what's going on. So make space like this. Okay, and then let's go into our database and change field and set this to true, update. Okay, so received a snapshot with 9 documents. Now it would be really nice if I got more details. Come on. Pretty please. There we go. And again, I should have been more patient. Okay. So here is the listen response. So we get this document here, and we can see all the fields in the document. More fields. It's still the same document. And that's it. So it's just this one document that was changed that is actually received on the wire. Everything else is fetched from the cache, right? So, and that actually makes sense, right? Because the way how Firestore queries work is, or Firestore snapshot listeners work is, the SDK talks to the server and says, well, this client here is interested in this query and in receiving this collection, and can you please monitor this query, and whenever there is a change, please let me know, right? So we basically have a watchdog monitor running on the server for each snapshot listener, and whenever there is a change, for example, somebody makes a change to that collection or to that query that you're listening to, this listener will be alerted, and then it will take the delta and send it down to the listening client. And it's absolutely vital that we're only sending the deltas, because why would we want to send everything down the wire if we can just send the delta? So that is what we're doing. And all the rest is being fetched from the local cache. You can also specify that you just want to fetch from the local cache. So that's also possible. You can say, well, the source of my data should be the server, or it should be the cache, or if you don't specify anything, it'll do what we just saw. It'll merge the data together with, fetching data from the server if it's online, and if it can't reach the server, it will fetch data from the cache. Okay, cool. So I'm happy that this worked out now, and we've got a new person joining on the stream. Hello, Jesus. Good to have you on the stream. So let's look at what we need to do in order to complete this implementation. So when I ran the application, you notice that we can't, this doesn't work. So if I toggle the read indicator, it doesn't really toggle, and the flag indicator also doesn't toggle. And this probably works, but if we restart the application, it will reappear. Why does it work? Because this swipe indication, action works on the collection under the hood, and but it doesn't synchronize with the data store. So let's see. Carter asked if there is anything wrong with listening to multiple snapshots at once. So no. So you can have multiple snapshot listeners set up. So for example, you might have a snapshot listener that listens to one collection. You might have another snapshot listener that's listening to another collection or to a different query. So that is something that I would actually expect to happen quite frequently in most applications. And even if you have multiple snapshot listeners listening to the same collection, that's also fine. One thing to note, and this is probably something that I'm the one to blame for, or maybe our documentation. It seems like a lot of people think that the only way to use Firestore is to use snapshot listeners, and that is not the case. So snapshot listeners are one of the magic pieces of Firestore, because, the real timiness of things is quite magic, and it's really impressive to be able to see that when you make a change here, it appears over here almost immediately, right? So, and that is why we love it. But you can also do a one-time fetch. You can just say, well, get me all the documents that match this query, or get me all the documents in this collection, or get me all of the user's documents in this other collection here. So do a one-time fetch. So if you want to implement a pull to refresh metaphor in your application, you can totally do that with Firestore. And it might, for some use cases, it might actually be the right thing to do. So let's see. Clemens asks, writes to cache and responses right away before it was performed over the network. Okay, so you it seems like you're responding to something that I did. One of the reasons why we have the cache is it's also for latency compensation, right? So we want to make sure that when the user makes a change locally, that it is persisted right away, right? So what happens is when you change something, it's being written to disk right away, and then Firestore tries to send it to the server. So you might not be online, or there might be other reasons why that call might not go through immediately, or it might be slow if you're on a slow network. So that is why this remote persistence might take a while, and even if it goes through, and even if you are on a very fast network, it will still be a lot slower than writing to disk. And that is why we have this write to disk first, and then try to update the remote system in the next step. And this also means if you're using a closure when adding a document to Firestore, this closure will be called back once the write goes through. So that means if you are offline and you write a document to Firestore, the closure will not be called back. It will only be called back once the document has been written to remote storage. So that's something to keep in mind. Cool. So with that, let's implement all the other methods here. So what we want to do is we want to remove an artifact. So yeah, it's probably a good idea to get the artifact ID, and then so Copilot suggests that we should use a closure. Let's do it without the closure. So collection name. Oh no, I didn't want to finish the entire thing. So document. And now is the moment when we need the document ID. So thanks, Clemens, for reminding us that we need to store this. So so here's another thing. So if you do .document, you can provide a document path. So that document path is relative to where you call .document from. So what we're doing here is we call it on the collection, but you could also do this, right? So you could call it directly on the Firestore instance. And then you'd have to put together the path yourself. So I personally prefer doing it the other way around, because I usually know which collection I am in. Now this is really confusing. So I know which collection I am in. We have the collection called collection name, and then we want to get the document, and the ID is the ID that we get from the artifact. So this one here, and then we want to delete the document, and that is it. So that should be it. Let's give it a try. And I'm going to pull up my browser in the backend, get the application into the foreground. Stay hydrated. Okay. I wonder if there is a breakpoint. Oh yes, we are. Okay. Okay. That was a breakpoint. Okay, so let's try removing it. And let me bring this to the foreground. Okay, so now when I delete something, we should see it flash in the background in the Firestore console. Maybe that was too quick. Let's try it again. Yeah, okay. I was expecting it to flash right. Maybe it's just the latency of the UI. Boom, it's gone. Okay, cool. So that works. Let's implement the other functions as well. And I need to make more space. Okay. Okay, so let's go and implement toggle read. So to do that, again, if let ID equals artifact ID, we need to know which document we are working on. And now we want to edit that document. And again, we're going to take the same approach that we used a little bit before, where in our memory implementation here, we're just updating this one field, right? Because now we actually might have the situation that somebody else is updating this document in Firestore while the user is making a local update. So that might, that is not out of the expectation. So database.collection collection name. What's the collection name? Collection name is collection name. That makes sense. And then we want to get the document with the ID, and then let's take a look at what are which methods are available. So we've got set data, and we can set the document data, and you can see in the code completion that this expects a dictionary, and that's not what we want. So we want to pass in our artifact as a struct. So let's look for a method that starts with from. So here are all the methods that start with from. So set data from, and merge, set data from and merge fields, right? So, and from the second parameter, you can tell that these are probably for something where we want to merge our edited document that we have locally with the one that's in the database. So we could either use the set data, and that means that the document is overwritten in the database, or we could use merge. So let's use this, and then we're going to use artifact, and then merge is true. So, but if we do this, nothing would be updated. Because the artifact that we pass in still has the old state. So, and we also need to make sure that we call this with try, do catch, and print any errors. An error occurred when writing the document, and then let's print the error. Why not use the update data method? Yeah, we could probably also use that. Unterminated string literal. Let's try it this way first, and then let's look at the update data. So set data, merge true. And before we do that, var updated artifact equals artifact, and then updated artifact dot is red dot toggle, right? So we want to update this. We want to change this. Let's give it a try. build succeeded. Here is the app. And now toggle red. And it's not working. So why is it not working? Okay, here we go. So we have the updated artifact. And it was unread. So is red. So this is false. No. It was unread. So now it's red. We have our artifact. Okay, so I see. Yeah. So we need to use this one down here. Okay, let's do this again. Okay. So let's call this, and now it works. Yep. Okay, so now to Clemens' suggestion. So he suggests to use the update data method. So let's implement this, and why not implement this on the toggle flag? So I'm just going to copy this entire chunk of code here, and then we're going to use Clemens' suggestion and see this side by side, right? So let's first of all, let's do it right here. So dot update data, and then you provide the fields that you want to update. Okay, so and we want to update the is flagged field, and we provide the value, and that looks good. No calls to throwing functions occur within try. So this isn't even throwing. So we can remove all of that, and then we also don't need this, right? Okay. Oh, we do. Okay. Cool. So let's try this, and I'm pretty sure it works. Okay, so this is for flagged. So this artifact here is not flagged. Let's flag it. Okay, so this didn't work. Okay, debugger is our best friend. Here we go. Okay, updated artifact. So let's see. Is flagged as false. Toggle it. Oh, there you go. Is flagged. All right. My bad. Yeah, you need to be careful when copying and pasting code. Okay, let's do it. Okay, so we toggled it, and it should be is flagged. It's true now, and then let's just continue, and there we go. So it's flagged. Let's do this again without the breakpoint so we can enjoy it. Yeah. Okay. So it seems to be working, right? So why would you choose one over the other? So I'm going to show you why this one here is my, using set data is my preferred way of doing things. And the reason is it's more type safe, right? And you can probably already see where this might become a problem here. So let's imagine that we decided, instead of calling this is flagged, we want to call it is start. So I'm going to do a refactoring here, refactor, rename, and I'm going to call it is start. And Xcode is pretty good at finding all of the occurrences of is flagged, but it doesn't find the string, right? So let's rename it. Okay. And then go back, and let's just assume that I didn't spot this, right? So I didn't spot that we now have renamed this to isStart. So if I now run this, okay, so now if I run this, the app will no longer compile because, okay, well, it will compile, but it will no longer work because what's happening now is, if we look into our database, the field is called isFlagged, as we originally called it. And now we're trying to map this, and the mapping fails because it's trying to map this using the field name that we used in the database. So, and we can actually make this visible here, catch, print error, return nil, and okay, right. So let's run this, and now we should be seeing a bunch of errors, which tells us that our mapping failed. Yeah, here we go. So error decoding artifact, key not found, isStart, right? So, so if you imagine that you refactor your application like we just did, and then you update your database, and then let's do this. So I'm going to go in. So we can't change the names of the attributes here, but let's create a new attribute, right? So is start is Boolean and it is true. Let's just add them and let's all make them true. Is start bool is true, and add another one here. Bool is true. One more. And a final one. Okay. Now the mapping should work fine. Right, so the mapping works fine. And let's go back into the database, and I'm going to delete all the isFlagged fields because we renamed it, right? So let's imagine that we are in this big refactoring. Our database looks like this. Instead of isFlagged, everything is called isStart. Okay, so now let's look at this document here. Now, once I do this, the isFlagged field appears. Why did it happen? Well, what should have happened is because our data model says, well, we have an artifact and the name of the attribute is isStart. What should have happened in the database is that the isStart field should have changed. But we were using the update data method, which requires us to use a string to specify which field we want to update. And so we forgot to change that. And now we're writing into an existing or into a different parameter. So, you know, that is why I think using zData is a better choice if you're using Codable, because that will, you know, make it harder or almost impossible to run into this situation. Yeah, good luck updating all clients at the same time. Well, so, and here's another thing. So let's assume that you actually want to migrate your data model, right? So let's assume that we want to, let's assume we roll out this version of the application, and now we want to change the data model, right? So for most of the documents that are in there, the field is now called is_start, and we want to call it differently in our application here. So if you remember how Codable works, you can provide a coding keys struct to specify how you want to name your fields. So let's go here, and in the documentation, I think we somewhere customize the mapping. So in this section, we explain how to do that. So we'll have to provide an enum inside our Codable, and then we can change how the data is mapped. So coding keys are conform to string encoding key, and now we can specify that our field here should be named differently, is flagged. Okay, so why? Okay. Okay. Well, let's see if we can get around that by putting it up here. Okay, it does not. Okay. Yeah, we need an initializer. Okay, yeah, because, and that is what I was worrying about. We need to provide we need to add all of the keys for all of the fields that we want to map. So let's do it. Let's do it. Okay. So we're going to specify all of the attributes we want to map. It's a little bit cumbersome, but it'll be complete. Schema versioning, yeah, you'd have to implement that yourself. You could probably, come up with something where you have different versions of the struct, and then use an identifier on the struct to decide which version you want to use. That might work. Okay, so is_start. I could just copy this, right? So let's do it this way. Okay. Okay, almost done. Okay, so, and now the is_start, we wanted to use a different name for the attribute. So, bam, let's see. Does this compile? Okay. Okay, so, but that does not solve the problem that you cannot change the schema of a deployed app without breaking clients. Well, not sure. I think, so if we decided to store the data differently, what I would do is I would start for the new clients to store the data in the new format, and for the old ones using the old format, and the new ones need to still write the old old format probably. Or maybe we need to write a Cloud function to migrate or to update data so that it works for both the old and the new clients. But it's not impossible. So I think it would work. Okay, so let's go back. So this is the first document here, and then now when I do this, nothing happens. Okay, great. Oh well, this start is flagged. Why is this not working? Okay, let's see if the so this seems to be working. Yes. Oh yeah. Okay, so this is because we write to the isFlagged field, and this is not going through the codable implementation. Okay, so let me just do it this way. And now is flagged. Oh. So it's called isStart in the struct. Let's double check. Okay. So now it's called isStart in the struct, but it's called isFlagged in the database. Okay, and here we go. Right, so it is updating this field like that. Okay, and for all the other ones where it's now called isStart, we basically would have to add another field to the struct or perform a migration on the document, on the database. So right, so in the database, it's called, so we've got isFlagged, isStart. Yeah, anyways, so long story short, I recommend using Codable, and we've now successfully managed to mess up our database. That is why I really prefer using Codable instead of using update data. So what I'm going to do is to clean this up, and instead of using the update data, we're going to use the Codable implementation. And because we don't really want to use isStart, you know, this is going to be called isFlagged again. So let's roll this back, and this is going to be a refactoring. Rename this to isFlagged. Okay, does it compile? Oh, we need to actually perform the refactoring. Okay, it succeeded. So now, yeah, so now we only have like this document here, and then on all the other ones, we would have to add the isFlagged field back again, or update our mapping code so that is more error resilient. So if we look at the documentation probably has a more error resilient way of doing this. Yeah, so you can see that here where if there is a failure, it will provide more detailed information. Then you can decide that, okay, even though it didn't map the entire document, I want to do a partial mapping. All right, so I think we almost achieved everything that I wanted to show you. There is one more thing. If we go back to our artifact store and come back to the original question of, hey, what about all those updates? Do I need to perform all those updates? Another thing that you can do is on the query snapshot document changes. So you can go over the document changes and then iterate over all of them. So you can do a compact map here and say, well, I only want to operate on the document changes. I'm not interested in all of the documents. I only want to do something on all the document changes. And then you get this document change in here. Change dot, and then you can see, okay, so here's the document. And then you can get the data, or you could get the old index or the new index. What else? Description. Yeah, that's something that's from the runtime. Let's actually look into, no, not that. Let's look into the change. Okay, so a document change. Document document change. So all it tells us is, oh, the change type. That is what I wanted. Okay, change dot type. Right. So that is the change type. Come on. So this can be added, modified, or removed, right? So you can determine what happened to the document. Was it a document that was deleted or something that was added or updated? Okay, let's see what we have on the stream here. Okay, so Carter asks, if the field is a CG float, will the Firebase numbers still get mapped correctly? That is a very good question. I would assume that it will get mapped correctly, yeah, we're already over time, but let's give it a try. Let's go here. Public var some float is a CG float, and let's do it that way. Okay. All right. So, and now let's go back into here, and I'm going to just add all the documents again into the database. You know, I'll seed the database with stuff from our mock data. So we should see a new field in the database that is of type number or something like that. So some float is 0, okay. So let's try 0.8. Okay, so, and here we go. Hello. I'm not sure. You know what? Let me delete the entire collection. And let's do this again. Okay, so now it should be easier to see our documents. And there you go. Some float is 0.8. So yes, you can map a CG float. All right, cool. So let's wrap up. All right. So that was fun, and also a little detour. I prefer Codable, but you can definitely use update data, but you got to be careful. So if you refactor code, you need to make sure that you update the stuff. Okay, so thanks for the lively discussion, folks. That was fun, and I hope the lag of half a minute wasn't too bad. So yeah, I hear a chime whenever you send a message, so that really helps. And for the next one, let me switch here. Yeah, this is out of date. Yeah, I completely messed this up. I'm sorry. So in the next one, I think we need to start looking into building out more of a UI for adding stuff into our database. So I've got a couple of things in mind. So ultimately, we want to end up in a place where you have a share sheet. So let's assume you are in the browser, for example, and you read an interesting article and want to save it into the application. There should be a share sheet, and in the share sheet, you can tap on the application's name and the stuff should be sent directly into the application. So that is one way to do it, but it might be good for the user to maybe be able to take some notes. So we need a form or a dialogue that the user can use in order to put in their notes or tags or whatever. And so I think next time around, we're gonna implement this dialogue and use it from inside the application. Another thing that I wanted to try out is reading the clipboard. So let's assume you are in the browser, you copy the URL, and then you come back into the application. We can read the clipboard and detect if there is a URL and then ask the user, hey, there seems to be a URL. Do you want to store this URL into your knowledge base? So that's what we're going to do next time. And although I did get the title wrong, the date and the time is correct. So it's going to be November the 20th. And it's Wednesday. It's not Friday. Oh my God, what did I do? Anyways. So yes, so Carter asked, when will the Gemini integration be implemented? That is going to be what we do right after that. So we need to have a way to put stuff into the database before we can actually start calling Gemini. So bear with me. There is going to be lots of AI stuff going on in the episodes after the next one. All right, thanks again for joining. I hope you got something out of it, and please dial in next time. All right, cheers. Have a good one.